The entity relationship model was introduced and formalized by Chen in 1976. It is one of the most popular data models for conceptual data modeling. It has three building blocks: entity types, attribute types, and relationship types. Entity types are similar to record types in the hierarchical or codicil model. The R model supports simple attribute types, composite attribute types, single-valued attribute types, and multi-valued attribute types. Relationship types can have any degree, such as unary, binary, ternary, etc. All cardinality ratios are supported, such as 1 to 1, 1 to n, n to 1, and m to n. Relationship types can also have attribute types. The R model has an attractive and user-friendly graphical notation. Hence, it has the ideal properties to build a conceptual scheme or model. An entity represents a business concept with an unambiguous meaning to a particular set of users. An example could be a particular student, product, supplier, or employee. An attribute represents a property of an entity. A particular entity will have a value for each of its attributes. Think about a student's name, a product's color, or a supplier's address. An entity type defines a collection of entities that have the same attributes and represent similar business concepts. In other words, entities are said to be instances of that particular entity type. An attribute type defines a collection of similar attribute values. An attribute value is an instance of an attribute type. Here you can see all four concepts illustrated. We have an entity type supplier with attribute types, supplier number, supplier name, supplier address, supplier city, and supplier status. Entities then correspond to specific suppliers such as supplier number 21, Deli Wines, together with all its other attribute values. A domain specifies the set of values that may be assigned to an attribute for each individual entity. A domain gender can be specified as having only two values, male and female. Likewise, a date domain allows to define dates as day, followed by month, followed by year. By convention, domains are not displayed in an ER diagram. A domain can also contain null values. A null value means that a value is not known, not applicable, or not relevant. It is thus not the same as the value 0. Think about a domain email address, which allows for null values in case the email address is not known. Various categories of attribute types exist, such as key attribute types, simple versus composite attribute types, single versus multi-valued attribute types, and derived attribute types. Let's take a closer look. A key attribute type is an attribute type whose values are distinct for each individual entity. In other words, a key attribute type can be used to uniquely identify each entity. Examples are supplier number, which is unique for each supplier, product number, which is unique for each product, and social security number, which is unique for each employee. A key attribute type can also be a combination of attribute types. As an example, suppose a flight is identified by a flight number. However, the same flight number is used on each day to represent a particular flight. In this case, a combination of flight number and departure date is needed to uniquely identify flight entities. It is clear from this example that the definition of a key attribute type depends upon the business setting. A composite attribute type is an attribute type that can be decomposed into other meaningful attribute types. Think about an address attribute type, which can be further decomposed into attribute types for street, number, zip code, city, and country. A multi-valued attribute type is an attribute type that can have multiple values. Diploma can be a multi-valued attribute type of the student entity type in case a student can have multiple diplomas. Likewise, email address can be a multi-valued attribute type in case a supplier can have multiple email addresses. A derived attribute type is an attribute type which can be derived from another. Age is a derived attribute type since it can be derived from birth date. Here you can see this illustrated. We have an entity type supplier. Note that entity types are represented as rectangles in the R model. Attribute types are represented using ellipses. Address is modeled as a composite attribute type consisting of attribute types for street, number, zip, city, and country. Supplier number is underlined since it is the key attribute type. The double line for the email attribute type indicates that it is multi-valued. Finally, the dashed line for the age attribute type indicates that this is a derived attribute type, calculated based upon birth date. A relationship represents an association between two or more entities. Consider a particular supplier supplying a set of products. A relationship type then defines a set of relationships among instances of one, two, or more entity types. Here you can see the concept of a relationship type illustrated. The supplies relationship type models which supplier can supply what products. Relationship types are indicated using a rhombus symbol in the ER model. Basically, the rhombus can be thought of as two adjacent arrows pointing to each of the entity types. You can see this illustrated here for the relationship type supplies between the entity types, supplier, and product. The degree of a relationship type corresponds to the number of entity types participating in the relationship type. A unary or recursive relationship type has degree 1. A binary relationship type has 2 participating entity types, whereas a ternary relationship type has 3 participating entity types. The roles of a relationship type indicate the various directions that can be used to interpret it. Here you can see our earlier relationship type. It is a binary relationship type since it has 2 participating entity types. Mind the role names which we have now added in each of the arrows, making up the rhombus symbol. Here you can see 2 more examples. The supervisor's relationship type is a unary or recursive relationship type since it models the hierarchical relationships between employees. The role names supervises and supervised by are added for further clarification. The second example is an example of a ternary relationship type booking between the entity types tourist, hotel, and travel agency. Role names can also be added, but this is less straightforward here. As in the hierarchical and codicil models, every relationship type can be characterized in terms of its cardinalities. More specifically, the cardinality specifies the minimum or maximum number of relationship instances that an entity can participate in. The minimum cardinality can either be 0 or 1. If it's 0, it implies that an entity can occur without being connected to another entity. This can be referred to as partial participation. In case the minimum cardinality is 1, an entity must always be connected to at least one other entity. This is referred to as total participation or existence dependency, since the existence of the entity depends upon the existence of another. The maximum cardinality can either be 1 or n. In case it's 1, an entity can be connected to at most one other entity. In case the maximum cardinality is n, an entity can be connected to at most n other entities. Relationship types are often characterized by means of their maximum cardinalities. For binary relationship types, this gives 4 options: 1 to 1, 1 to n to 1, and m to n. Here you can see some examples of binary relationship types together with their cardinalities. A student can be enrolled for minimum 1, maximum m courses. Vice versa, a course can have minimum 0, maximum n students enrolled. This is an example of an n to m relationship type. A student can be assigned to minimum 0, maximum 1 master thesis. Vice versa, a master thesis is assigned to minimum 0, maximum 1 student. This is an example of a 1-to-1 relationship type. An employee can manage minimum 0, maximum n projects. Vice versa, a project is managed by a minimum 1, maximum 1, or in other words, exactly 1 employee. This is an example of a 1-to-n relationship type. Here you can see the same relationship types visualized using an alternative notation, whereby the minimum cardinalities are now represented using either single or double lines. Although some textbooks or tools use this notation, I personally don't like it very much since I consider it confusing. Similar to entity types, a relationship type can also have attribute types. These attribute types can be migrated to one of the participating entity types in case of a 1-to-1 or 1-to-n relationship type. However, in case of an m-to-n relationship type, the attribute type needs to be explicitly specified as a relationship attribute type. You can see this illustrated here. The attribute type, hours, represents the number of hours an employee worked on a project, and is thus uniquely determined by a combination of both employee and project. Hence, it needs to be modeled as an attribute type of the works on relationship type. Weak entity types are a special class of entity types. These are entity types that do not have key attribute types of their own. More specifically, entities belonging to a weak entity type are identified by being related to specific entities from another entity type, the owner entity type, in combination with some of their attributes, called partial keys. A weak entity type is always existence dependent from this owner entity type. Vice versa, however, an existent dependent entity type does not imply a weak entity type. Let's illustrate this with an example. Let's assume we make an ER model for a hotel administration. A hotel has a hotel number and a hotel name. Every hotel has a unique hotel number. Hence, hotel number is the key attribute. A room is identified by a room number and a number of beds. Within a particular hotel, each room has a unique room number, but the same room number can occur for multiple rooms in different hotels. Hence, room number as such does not suffice as a key attribute. Consequently, the entity type room is a weak entity type since it cannot produce its own key attribute type. More specifically, it needs to borrow hotel number from hotel to come up with a key attribute type, which is now a combination of room number and hotel number. Note that obviously, room is also existent dependent from hotel, as indicated by the minimum cardinality of 1. Here you can see another example. The purchase order entity type is existent dependent from supplier as indicated by the minimum cardinality of 1. However, in this case, purchase order has its own key attribute type, which is purchase order number. In other words, purchase order is an existent dependent entity type, but not a weak entity type. To summarize, a weak entity type is always existent dependent, but an existent dependent entity type is not always a weak entity type. Assume now that we have a problem situation where suppliers can supply products for projects. A supplier can supply a particular product for multiple projects. A product for a particular project can be supplied by multiple suppliers. A project can have a particular supplier supply multiple products. The model must also include the quantity and due date for supplying a particular product to a particular project by a particular supplier. This is the situation which can be perfectly modeled using a ternary relationship type, as you can see illustrated here. A supplier can supply a particular product for 0 to n projects. A product for a particular project can be supplied by 0 to n suppliers. A supplier can supply 0 to n A supplier can supply 0 to n products for a particular project. The relationship type also includes the quantity and due date attribute types. The question now is whether we can also model this ternary relationship type as a set of binary relationship types. You can see this illustrated here. We decompose the ternary relationship type into the binary relationship types supplies between supplier and project, can supply between supplier and product, and uses between product and project. We can now wonder whether the semantics is kept by doing this. To understand this, we need to write down some relationship instances. Assume we have two projects. Project 1 uses a pencil and a pen, and Project 2 uses a pen. Supplier Peters supplies the pencil for Project 1 and the pen for Project 2, whereas Supplier Johnson supplies the pen for Project 1. First, you can see the relationship instances in case we would use a ternary relationship type supply. We then also included the relationship instances in case we would use three binary relationship types: supplies, uses, and can supply. From the binary relationships, it cannot be seen that Peters does not supply the pen for Project 1. More specifically, both Peters and Johnson supply for Project 1. They can also both supply a pen. Hence, from the binary relationship types, it is not clear who supplies the pen for Project 1. This is, however, clear in the ternary relationship type. Hence, by decomposing the ternary relationship types into binary relationship types, we clearly lose semantics. Furthermore, it is also unclear where we should add the relationship attribute types such as quantity and due date. Binary relationship types can, however, be used to model additional semantics. Here you can see another example of a ternary relationship type. An instructor can offer a course during 0 to n semesters. A course during a semester is offered by 1 to n instructors. An instructor can offer 0 to n courses during a semester. In this case, we also added an extra binary relationship type qualified between instructor and course to indicate what courses an instructor is qualified to teach. Another alternative to model a ternary relationship type is by using a weak entity type, as you can see illustrated here. The weak entity type supply is existent dependent from supplier, product, and project. Its key is a combination of supplier number, product number, and project number. It also includes the attribute types quantity and due date. Representing a ternary relationship type in this way can be handy in case the database modeling tool does not support it. Here you can see the ER model for the HR administration example. Let's read some of the relationship types. An employee works in minimum one, maximum one, or does exactly one department. A department has minimum one, maximum n employees working in it. A department is managed by exactly one employee. An employee can manage 0 to 1 departments. A department is in charge of 0 to n projects. A project is assigned to exactly one department. An employee works on 0 to n projects. A project is being worked on by 0 to n employees. The relationship type works on also has an attribute type hours, representing the number of hours an employee worked on a project. Also note the recursive relationship type to model the supervision relationships between employees. An employee supervises 0 to n employees. An employee is supervised by 0 to 1 employees. Here you can see another example of an ER model for a purchase order administration. It has three entity types: supplier, purchase order, and product. A supplier can supply 0 to n products. A product can be supplied by 0 to n suppliers. The relationship type supplies also includes the attribute types purchase price and delivery period. A supplier can have 0 to n purchase orders on order. A purchase order is always assigned to one supplier. A purchase order can have 1 to n purchase order lines with products. Vice versa, a product can be included in 0 to n purchase orders. The relationship type also includes the quantity of the order. Also note the attribute types and key attribute types which are underlined. Although the ER model is a very user-friendly data model for conceptual data modeling, it also has its shortcomings. First of all, the ER model presents a temporary snapshot of the data requirements of a business process. This implies that temporal patterns cannot be modeled. Some example temporal rules which cannot be enforced are: a project needs to be assigned to a department after 1 month. An employee cannot return to a department of which he previously was a manager. An employee needs to be assigned to a department after 6 months. A purchase order must be assigned to a supplier after 2 weeks. These rules need to be documented and followed up with application code. Another shortcoming is that the ER model cannot guarantee the consistency among multiple relationship types. Some example business rules are: an employee should work in a department that he/she manages. Employees should work on projects assigned to departments to which the employees belong. And suppliers can only be assigned to purchase orders for products they can supply. Again, these business rules need to be documented and followed up with application code. Finally, it is not possible in the ER model to include integrity rules or behavior, such as hours has to be a positive integer, prod type must be red, white, or sparkling, or procedure to calculate an employee's salary.